All right, good. So it's 2 o'clock, let's get this thing going. This is the talk about multi-cloud CI/CD with OpenStack and Kubernetes. All right, so first, a few words about myself. I'm Maxime. I'm a freelance cloud consultant based in Brussels, Belgium. I work with public and private cloud projects, specialize in OpenStack, Kubernetes, Ceph, and CI/CD. Usually it's a combination of all the above. And that's probably enough about myself. You didn't come to listen about my life. The slides are available online, so you don't need to take like photos or whatever. You can follow the links. All the source code is linked into the slides, so you can take it easy. I'll jump in with the introduction before going into the technical aspects. So the talk is focused on multi-cloud, but first let me put a bit of context about what do I mean with multi-cloud. Maybe different people mean different things, so it's better to talk about it. So multi-cloud, in its most basic principle, is to have different cloud providers or service providers. And the most common motivation for that is customers want to have resiliency. They don't want to have all their eggs in one basket. They want to, in case of something happens with a given cloud provider, maybe a region outage or an AZ outage, they want to be able to transition quickly and seamlessly for their application into some other cloud provider. That's, I think, one of the most common motivation for multi-cloud. There is also the vendor lock-in aspect, which resonates very well with the OpenStack and the 4 opens. You don't want to be too locked in with one provider because maybe one day they do something you don't like, maybe they increase prices, and if you're locked into that one, it's going to take you a while to do something about it, to migrate to some other cloud provider or something like this. If you already have a multi-cloud strategy, you can simply scale down your infrastructure in that cloud provider and then scale out into the other ones the next day or the same day, basically. So that's an interesting value proposition for some customers. There's also the cost aspect. So, like I said, if one cloud provider doesn't have a very good pricing or very interesting pricing on one area, the other ones might have something better in a better offering into some other areas. But also a lot of people want to do a hybrid cloud, like having their baseline workload running into their own private cloud environment, on-prem most of the time, and do cloud bursting to a service provider to handle sales season or Christmas time or something like that. So this is a fairly common motivation for multi-cloud. Another one are the features. With your cloud, you could have like so many features, but some cloud providers will focus on some features and have very good offering on AI or GPU instances, and some other providers will have maybe better network connectivity or things like this. So it can be interesting to like take the best for your use cases. If you need both great network connectivity and great GPU capacity, well, maybe you need to work with several cloud providers because there's not one provider that has everything that you need. So sometimes you have to. And kind of the last one I've written down there is the locations. Some providers, they will focus into Europe locations, some providers will focus in Asia, some will focus in the US, and maybe your customers, they are spread all around the world, and you need to have low latency or things like this. So you might also have to go with different providers to reach different regions that are not reachable with, say, AWS or GCP or something like this. So that's my take on multi-cloud here. Then the other big area of the talk is CI/CD, so continuous integration, continuous delivery. Here the idea is to accelerate the business, to be able to go fast and to fail fast. We don't want to invest a lot of developer time and to spend a lot of effort and then to realize, well, this thing didn't work out, now we lost 6 months. So it's better to realize that as soon as possible and keep iterating in short cycles. So this is what CI/CD helps there. And for this to happen, you really need a really good automation. You need to focus on automation because if you want to do hundreds of deploys per day, this is not going to be sustainable to do this by hand or by sending a ticket to somebody to, oh, please release this new version of my application across the globe. So this is really something you need to focus on, especially since we're talking multi-cloud, we'll have all different clouds, and we want to have a very good consistency between those clouds. If we do things manually, there's a big chance we're going to have small differences between each time somebody did this thing manually. And then we might end up in situations where we have a bug that happens only in this instance or in this provider. And that's really difficult to find and to fix. So really important to focus on automation, even though it can be hard. All right, OpenStack and Kubernetes. So that's here. Well, it's the OpenStack Summit, right? So we need to talk about OpenStack. So OpenStack here will be our API-driven infrastructure as a service. It will provide the open infrastructure platform based on whichever Cinder and Nova driver you have into your OpenStack cloud. What's really interesting with OpenStack is that you have a big choice of public clouds available out there. I think more than 60 are available in the marketplace, probably openstack.org/marketplace. And you can check the full list there. And there's probably one close to you, so I think this is really interesting. And on the Kubernetes aspect, Kubernetes here is going to be our container orchestration platform, which is maybe more developer focused. People, they can install Kubernetes very easily on their laptop nowadays. And they can have something that they can easily reproduce between the production environment and their laptop, just using Docker containers. That's really the benefit there. So not only they can run Docker on their laptop, but they can run Kubernetes on their laptop and have the same experience. That's what's going to happen in production, so you can find problems easier. Of course, Kubernetes, since it's based on Docker, it's going to provide you with the portability. Your container that runs on your machine is exactly the same as the container that runs in the cloud or in your production environment. So you don't have this hard-coded library that's based on your whatever you have on your laptop and it's not available into the production servers, and then you run into problems. So this is like really makes things much easier there. All right, so I kind of divide this into two aspects: the control plane, which is on your right, and the data plane that's on the left. The data plane, this is where your customers will work, let's say. So your users at the top there will talk to your application will talk to Kubernetes, and Kubernetes will talk to OpenStack. And this happens really fast. This is like the data plane. This is where all the data goes. And on the right-hand side, you have your control plane. So this is where your DevOps, your developers, or your ops people will work. They will talk to some form of CI/CD platform. Here I put GitLab, but pick whatever you're most comfortable with. And then this CI/CD platform will make things happen into the business logic, into the container platform, and into the infrastructure as a service when and where appropriate. So this is like the very high-level idea of this talk. And I'll go a bit deeper into that architecture now. All right, so when your customer is going to wants to reach your application, the first entry point they have is they're going to enter a DNS name or some form of URL. So this is really like the scope of the place where we start. So they're going to enter the address of your application, and you're going to need to do some form of global load balancing because you're multi-cloud. You're going to need to send this request to this or that other cloud based on whatever policy or metrics you have defined. And there you have a couple of possibilities. You could do something with Anycast. Usually that's not really available in public cloud providers, but if you are private cloud based, maybe that's an option you have. Another option is to do something based on a CDN. So you would have your CDN handling your global load balancing, and they have Anycast network, they have all these capabilities to load balance your request and route it to wherever is most appropriate. And you might be already using a CDN, in which case it's really a drop-in a feature to enable in your CDN provider. And kind of a third option you have is to do something based on DNS, so that when the customer enters the DNS name, it would resolve to an IP that's coming from that cloud provider or that other cloud provider. That's a really simple thing to do. Maybe you have a bit less control. And there you could do something based on geo-routing, and that's available in Route 53 at AWS, or din.net, I think. And if you go the open source route, you can do geo-DNS, I think. You could do something with some custom scripts that handles dynamic DNS updates based on whatever business logic you have or metrics you have. Or a very simple option is to do just DNS round robin and round robin between a list of cloud providers. The last one is you need to consider the latency, right? If you do DNS round robin with West Coast and Tokyo, well, 50% of the time you're going to hit high latency link or low latency link. So it depends a lot on your use case. If your data centers are close by, that's more suitable. All right, so now our request is load balanced. And here I have an example of 3 clouds. So we're going to hit the application. And here I'm assuming that the application is somewhat of a 12-factor application. There is this manifest about the 12-factor app. So that's like stateless apps and all that stuff. Your application has to be Dockerized, right? We want to run this in Kubernetes, so we're going to need to containerize our application. Your application has to be HTTP based. Otherwise, we'll have difficulties to load balance it, and it doesn't fit really well in Kubernetes if it's non-HTTP application. And also, it has to be able to run into a distributed fashion, ideally active-active mode, so that we can load balance and not just have active-passive capabilities. Right, so now we hit the application, and the application runs on Kubernetes. And Kubernetes here will provide our cloud abstraction layer, because each cloud provider, even though they are all OpenStack, they have small nuances. So here we can talk one API, and then it will take care of those nuances for us, and will abstract those nuances. So this is what I mean by the cloud abstraction layer. What's really, really, really important is to do one cluster per location. It's a really bad idea to do one cluster across several locations. You're kind of destroying the benefits you get from Kubernetes if you do that. So if there's one thing to remember is that don't do stretch clusters, basically. So yeah, we have one cluster per location, and then we'll take care of that there. Each cluster will have its own ingress controllers, so that's a Kubernetes concept for basically a reverse proxy or edge proxy. And then we'll have to do some form of Kubernetes federation. All right, so Kubernetes federation. This is a bit of a complicated topic. Depends if you come from OpenStack world or from Kubernetes world. It probably means a bit different things for you. If you come from the OpenStack world, federation is more of a one authentication thing that works across different providers. So this is possible in Kubernetes, and that's called authentication federation. You have basically 2 main ways that are available, that are commonly used. It's the OIDC or OpenID Connect options, in which case you provide your OpenID Connect provider address and client ID. And from that point on, your Kubernetes cluster will recognize tokens issued by that provider. That's available at Google, GitLab, GitHub as well. There are a bunch of providers out there, and you just configure those 2 parameters, and then the clients or the developers can have a single sign-on experience across the different Kubernetes clusters. The other option you have is to do webhooks. So Kubernetes will call this webhook every time it sees a new token to know, what is this token? What does it mean? Who does it belong to? Is it valid or not? And all those things. So this is more common for if you have your custom token thing. You're not using OIDC, you want to integrate with something else. You have that possibility. You need to write that webhook though. So that's what you have there. On the client side, you're going to need to tell the client to include those tokens. If it's a webhook thing, you're kind of on your own there. If you're using the OIDC, you have this parameter to pass in the CLI once per client, and then it sets this in the config file, and you're all set. Or there is also a UI that I will demo a bit later that generates the config file, and you just drop the file, and you're done. So that's the authentication federation. But Kubernetes, they made as well what they call kubefed. So if you're not from the OpenStack world, maybe more Kubernetes world, this is maybe more what you think about when I say federation. And there, this is a bit of a different story. The idea there is more one API endpoint to rule them all, kind of. So one API endpoint to rule a bunch of clusters. And this is really interesting when you do multi-cloud, because you would have just one place where you say, create my workload, and then things happen at different locations, and that's really interesting. Though this started out as kubefed v1, which got discontinued like 3 releases ago, and was supposed to be replaced by kubefed v2. Unfortunately, at this stage, kubefed v2 is a work in progress prototype, so it's not really suitable for today's production workloads. But if your project is a future project or something in a couple of months, maybe this is something worth looking into. But today you don't really have a production-ready option there for kubefed. So we're kind of left with doing some DIY things until kubefed becomes stable and usable in production. All right, so all of that runs on some form of resources, and in this case it will run on OpenStack. And this means that Kubernetes machines will be, Nova servers or instances, or ironic if your cloud provider or your private cloud has that capability. We'll need some form of security group to control firewall rules between our instances. We'll need some form of SSH key pairs, of course, to handle authentication to the servers. And something that can be interesting is to use Nova server groups to say, this group of maybe your etcd cluster in Kubernetes, this is really important that it doesn't run on the same physical boxes, so I will set an anti-affinity group there to spread the workload across several servers for resiliency reasons. You have also the neutron things that are required. We'll need a neutron network, a subnet, a router, some floating IPs, and that's kind of the features we would absolutely need from an OpenStack side, and we're not using too many of the fancy new projects. And of course you can enable more things like Octavia, Cinder and such if you need those things, but those are not absolutely required to keep moving. All right, so this is a lot of stuff that we need to make happen. And we are doing multi-cloud, so we're going to need some form of cloud agnostic tools to be able to work across different clouds to set all that up. And here, I'm not here to tell you that you should do this or you should do that. I'm kind of presenting you popular options, and it's up to you to choose what's most suitable for your environment. Well, we are at the OpenStack Summit, so we'll start with the OpenStack tool first, which is Heat to set up the infrastructure. And this is OpenStack Heat has been around for a very long time. It's OpenStack native. It's available in almost every single OpenStack cloud. Even public cloud providers have it. But that doesn't really help you for non-OpenStack clouds. If you want to do multi-clouds between AWS and your private cloud, well, Heat will not help you for AWS. So this could be a downside there. Heat also has somewhat of a smaller ecosystem. It's you're likely to be required to start from scratch when you write your Heat templates, which are the configuration files to talk to Heat. It's kind of difficult to find workable or production-ready Heat templates that just work. So this is also a downside. Maybe you have a lot of experience with Heat because you already use it a lot in your private cloud. Great, use that. Another popular option is Ansible. And Ansible does lots and lots of stuff. But here I'm really talking about the cloud modules, which is a subset of what Ansible does. And there you have a bunch of cloud modules for OpenStack, and they all start with OS underscore. So you have this OS server, OS floating IPs that allows you to say, well, I want this server, I want this many floating IPs, and create them in this and that way. This is really useful. Ansible is fairly easy to get started with. Most likely you use it already in your infrastructure, or it's extremely popular tool. So this is like kind of nice. And nice thing with the Ansible is it also has modules for AWS, Google Cloud, VMware, and a bunch of other clouds. So you're not stuck with one option. Like now you can really do cross-technology multi-cloud as well. And finally, we have Terraform, which is focused on only handling infrastructure. So compared to Ansible, which does a lot of stuff, one of those things being managing infrastructure. Here, Terraform handles only infrastructure and does it really well. But that's a new tool to learn, so doesn't work for everyone there. Since it's focused only on infrastructure, it has some extra features that are kind of nice. You can say, well, when you will use Terraform, it will tell you what it's about to do. So it's going to show you the plan. Okay, this is the VMs I'm going to create, or I'm going to change those, or I'm going to delete those. And then you can confirm or reject before anything happens. So that's a nice feature. And Terraform has even more exotic cloud platforms available out there in terms of modules. So lots of integration. So those are the things that are available for installing infrastructure. But once we have our infrastructure up, we're also going to need to install Kubernetes on that. And there I'll start again with the OpenStack native tool, which is Magnum. And again, it's OpenStack only. So if you want to do AWS and OpenStack, Magnum will help you on the OpenStack front, but not on the AWS front. But you probably have other tools for handling the AWS things. Magnum is a bit more recent project. The ecosystem is getting better and developing, but maybe not as developed as some of the other options out there. For instance, I think it doesn't have an Ansible cloud module yet, so you have to write, talk to the API directly to Magnum or handle things with the CLI client. You also have another popular tool to install Kubernetes, that's kops, which has no OpenStack support yet, or OpenStack support is in progress or very, very new. And this was focused only on AWS until now. So this could be like the example I was giving, like AWS OpenStack. Well, you could use Magnum for the OpenStack and kops for the AWS side. You also have another popular tool, Rancher. No direct OpenStack support, I think, but has bare metal support. Yeah, some other options there. Lastly, you have KubeSpray, which is basically a set of Ansible playbooks to install Kubernetes on basically any platform. Bare metal, AWS, OpenStack doesn't really matter. And it comes with a set of Terraform plans that you can use out of the box. So this is kind of nice to get started. You have plans for OpenStack. All right, so some more tooling we'll need is some CI tooling. There are a bunch of CI tools out there, and really, if you already have some good CI tool that you're happy with, continue there. Otherwise, you have Jenkins, GitLab CI, which is kind of nice since it has integration, deep integration with Git if you already use the GitLab UI. And what's kind of important is that to have a pipeline for your application to go in stages. So you're going to commit code, you're going to check this code you committed, you're going to build it, run some tests, and then you're going to run your code in staging, and then run your code in production. So this is like a general pipeline, but whatever is appropriate for your application. And it's important to run the tests so you can have confidence in your automation. Some other options out there that are Git-based, so you have with Flux and Argo CD that are Kubernetes-focused things, bleeding edge, GitOps style CI. All right, I think that's all for the slides, basically, and now it's live demo time, so let's hope things work out. Before I go in the demo, I'll explain how the demo is set up. So I talked a lot about different technologies. This is what I picked for the demo. It's what worked for me. No, if you choose something else, that's fine. I'm using DNS round robin. I don't have any cast. I don't have a budget for a CDN either. So I keep things simple. I'm using KubeSpray, which comes with baked-in Terraform plans. So I'm using those. And for the CI, I'm using GitLab CI with AutoDevOps, which is basically a wrapper around Docker build and Helm install. So no magic there into the CI thing. The demo runs on 27 different data centers, all running OpenStack, 18 different companies, and they run versions from Havana to Stein. So Havana, that's like 6 years ago, and Stein, that's latest release. So hopefully you have a wide variety of choice. If there's one bug that affects you into one release, the chances are doesn't affect all 18 companies. The source code for the demo is available at the link below, and you can check it out if you're interested. I need to give a big thanks to all the participating cloud providers. I mean, all of that wouldn't be possible without them, so big thanks to them. And then we can dig into the demo. All right, so this is the demo application I made. I'm not a graphics designer or web designer, as you can see. It's very simple, just says hello world. Here it says a city Stockholm, so that's the cloud that is serving this request, is the cloud that is in Stockholm. And then we can see the host name of the container serving that request, and a nice photo of whichever city we are being served from. So if I open this into another incognito window, now we're hitting the Tokyo server, and I'll open another one, and again Tokyo. So DNS round robin has some form of unpredictability. We cannot control too much, and now we're hitting Amsterdam data center, and I can do a couple of more if you like to see beautiful photos from around the world. London. I think you get the idea. We are just doing round robin there. The source code points to this group, which has 4 repos. The first 2 are kind of not really important. There is a Docker image to make things go a bit faster, so I don't have to reinstall everything from scratch every time. And then there's the auto-deploy app, and that's the Helm chart. So a Helm chart, that's a template for packaging a Kubernetes application, and that Helm chart is a fork of the GitLab made Helm chart, I suppose, to make it multi-cloud compatible, because otherwise they assume there is a single data center, basically. Then the application source code, and then there's another repo called clusters that handles the cluster management with infrastructure as code. So if we want to add a new cluster, a new data center, we add a file there, and then the CI will make the magic happen. So let's go to this app repo. I'll make so this is a simple Python app. I'll go to templates and index.html. You can see there, hello world. We're going to change that to hello Denver 2019. I'm going to commit to master. I know I shouldn't do that, but we don't have time to do code review for the demo, right? So let's just commit this to master. You should do merge request, code review, all that stuff, of course. And then I'm going into the CI. The CI picked up that there's a new commit, and now it's going to start to build the new Docker image, run some tests, and once all those things are green, we're going to start to deploy things everywhere. This takes a few minutes, so while this happens, I'm going to just pop up the map that I made, and everything is currently green, and as things get deployed, it's going to change color between blue, red, green, and then I can move on to show some other aspect of the demo. All right, so I'll just keep this on the side. Open the terminal. Yes. Now over here. So this is the clusters repo. In there you have a folder called Kuberos. And Kuberos, this is the application that generates the config files for SSO or single sign-on experience between different Kubernetes clusters. There is a, oh, I need to start the Docker daemon. There is a small kuberos.sh script. So here for the demo, I'm just running Kuberos locally, but you know, in real life, you would run this in your cluster or into some form of a web accessible thing. And then once Docker daemon is started, I will be able to run this. I should have started the Docker daemon beforehand, apparently. Forgot about that, sorry. All right, we're good. So now we have Kuberos running. We'll open the Kuberos window. It redirects you to the IDP, OpenID Connect Identity Provider. In this case, I have configured gitlab.com. Ask you, do you authorize this access? Yes, I do. And then I have this page here with some instruction if I want to do things manually, but I will just download the config file. And then I will move the config file from my downloads folder to my .kube/config location. And then that gets picked up by the kube control tool. I can do kube control get context, and then here we see all our data centers. And if we want to see information from one cluster in specific, we can just do -- context here. So kubectl or kube control get pods into Montreal, for instance. Since we're in North America, yep, we can see there are 2 pods there. Then we can see Stockholm as well. And this is really easy for your DevOps people or your developers because they have one thing, one config file, one identity, and you can handle things with as many Kubernetes clusters as you wish. All right, so this is nice. We can also set policies if we want to control access. So here I've set a policy that I have read-only access to all the API resources. So if I try to delete a pod, it should tell me that no, I cannot delete a pod. I don't have permissions for that. So you can set different groups or whatever. These people are allowed to delete things. Those people are allowed to create things. So this is the Kuberos thing. All right, and now here we are deploying. Still takes a little time. Yep. All right, we just have Berlin, Montreal 2, Strasbourg, and Tokyo left. And I will show in the meanwhile the clusters repo. So that's the repository that handles the infrastructure as code. And in there you have basically 2 shell scripts, one that creates a cluster, one that destroys a cluster, and you have a config file that lists all the clusters. So this is a pretty familiar clouds.yaml. And then there's a key value. There are dictionaries to define all the different providers. So Stockholm 1, Stockholm 2, Tokyo, Montreal, Prague, and a bunch of other ones. I had to comment a couple of those because there was some issues with a couple of providers. All right, and then the infrastructure as code then is based on pipelines as well for setting up clusters. We can just delete and create clusters through here. Up will create a cluster, and down will destroy a cluster, like I said. So let me just refresh here. We are hitting the Paris cluster, and we can go over there, look for Paris. We click stop, and it will start the procedure to delete the cluster, update the DNS record, wait a little bit, and then it's gone from the DNS round robin, and then we can Terraform destroy it, and we're done. And that's that. And here you notice now it says Hello Denver. So it got deployed all across all the clusters while we were waiting. And that's the demo. Yep, let's see, where are the slides? I will just finish the slides then. A little bit of wrap up. KubeFed v2 is coming. It's not yet there, but getting there. And it's going to make things a lot easier because one API to roll them all, one endpoint, and you can configure things much easier than to have a list of endpoints and do things there. OpenStack interop is kind of hard, actually. Different providers have different systems. Some will put firewall rules to access the APIs. Some will have support for neutral routers. Some will not. Floating IPs, not everybody has support for that. Glance images, most people use the official images. Some people just make custom images with whatever baked-in things they want, and that's not really easy to work with. You need to make a bunch of exceptions. VM flavors are also extremely different from providers to providers, and that can be tricky. And also, things change over time. Something that worked 6 months ago might not work today because they upgraded, they changed flavors, they did something, and the more clouds you have, the more difficult it is. Two key things to think about is when you do multi-cloud, do you do common denominator? Do you take the lowest level across all your providers, or do you do exceptions? And this is really on a case-by-case basis. You need to ask yourself, do I make an exception for this thing, or do I just take it out, basically? And the whole thing here is basically to start to treat clouds as cattle and not as pets, so that if there's a problem with one cloud, you can just nuke it, and that's it. So that's really the next step that I'm showing here. And that's it for the talk. I think we might have a few minutes for questions, and thank you for your attention. I think you can head to the mic.
Hi, great talk. I have a question. Can you describe the advantage of having one cluster than multiply? Because as far as I know, you can use it labels to describe which node you on target.
So one Kubernetes cluster is compared to several Kubernetes clusters. So it's going to depend a lot on your use cases. But let's say you want to do a Kubernetes upgrade, it's safer to do on one cluster at a time. And that way, if something happens, you can take that cluster out, take the traffic out of that cluster while you upgrade it, and then send the traffic back once you're happy with the upgrade. That's like a typical example of things. It comes back a little bit to the multi-cloud motivations there. So some people just have to do because there is not one provider that has all the features they need. So depends.
Okay. Another question.
Shoot.
About the Terraform, because you tell us that Terraform is provider agnostic. I'm not sure I agree with that, because you need to describe every provider in different way. Yeah. So it's not easy to, for example, migrate from one provider to another. You need to write, again, whole infrastructure. Maybe you find another tool that is fully provider agnostic, because I not yet find.
So there are tools that are trying to be provider agnostic, but to my knowledge, there is nothing that's like really good to use. Terraform, in this sense, can be considered provider agnostic, because if two providers are using OpenStack, you can use the same modules. Yeah. You might need to change parameters, things like flavor names, things around if this provider doesn't support neutron or floating IPs and that one does, you need to put different settings in there, but you will be able to use the same plans. And in this demo, it's all from the upstream KubeSpray Terraform plans, and it works with basically all the OpenStack.org/marketplace providers. So yeah, if you want to do Amazon, that's going to be some different code there.
Okay, thank you.
No problem. Any other questions?
Yeah. So I have seen, thanks for the presentation. In your case, your application is pushed across all clouds. Have you come across a scenario where your application constitutes several microservices running between clouds?
All right. So if your application has dependencies, basically?
That's right.
So in Helm, you could set dependencies that my application needs this and that dependency. So at runtime, it will resolve the dependency tree and install those things as well. So that's one of the options you have. Yeah, I think that's the most the simplest way to go. Then if it's like an API that you need to consume, then we will have to look at that a bit if you have more info.
Okay, thanks.
All right. Any other? Sure.
Thanks. Is there any option for percentage-based deployment?
I can't hear you.
When you did the deployment, it's like 100% deployment. Can you do it on a percentage-based?
To deploy the percentage base, I didn't cover this in the demo, but you can add some logic there to do by stages. Yeah, I suppose so. We can make things as complex as we want. Try to keep things as simple for demo. All right. I guess we're out of time. All right. Thanks, everyone.